So we've calculated pH of strong acids, strong bases, weak bases. And the last thing that we kind of want to look at is acid-base properties of salts. And by salt, we just mean any general ionic compound. Now we'll look at this a little more qualitatively in that we just want to be able to identify an ionic compound as either being acid, base, or neutral, but we don't necessarily need to calculate the pH. And so neutral salts, let's tackle those first. Neutral salts contain a cation from a strong base. And so cations are positive ions. So when I think about like the positive ion from a strong base, the two that come to my mind right away are things like potassium hydroxide, sodium hydroxide, probably like two of the most common strong bases. Well, the cation then is just referring to the positive ion. So we're referring to the potassium ion or the sodium ion. Okay, so the cation from a strong base, the positive ion from a strong base, and the anion from a strong acid. So anion is the negative ion, and two of the most common strong acids are things like HCl or HNO3. Hydrochloric acid and nitric acid are probably the two most common strong acids. Well, now I'm looking at the negative ion from these strong acids. So something like chloride or nitrate. So we're basically saying that if you put these ions together, you will have a compound that will have no effect on the hydrogen concentration in a solution. So think about, possible combinations. I could have something like potassium chloride or something like sodium nitrate. Obviously, I could have sodium chloride and potassium nitrate. When you're trying to figure out if an ionic compound can be acidic or basic, you ask yourself two questions. Well, if it's going to act like an acid, that means that there has to be an ion that is a hydrogen donor. There has to be something that can produce hydrogen, that can provide hydrogen to the solution. Yeah, there's no hydrogen anywhere in these compounds, right? So no, like potassium chloride, that can't act like an acid. It can't produce hydrogen. Sodium nitrate, that's not an acid. There's no hydrogen anywhere. The second question we ask is, are there any ions that could react with hydrogen and that could remove hydrogen from the solution? That would be the sign of a base. A base is a particle that accepts hydrogen. It can remove hydrogen from the solution. Well, then I'm usually thinking that it's something negative. But earlier we said that, like that chlorine ion is such a terrible base. If chlorine were in the presence of hydrogen, it never chemically changes. It would form a strong acid, which then would dissociate immediately. Same thing with nitrate. If it's coming from a strong acid, the conjugate base of a strong acid is an awful, terrible base. Hydrogen with nitrate would just split apart immediately. Chlorine and nitrate don't react with hydrogen. They don't form something that would remove hydrogen. It would totally ionize right away. And so these compounds then would be 100% neutral. Nobody can act like an acid and produce hydrogen. And those negative ions do not react with hydrogen either. If they would just immediately dissociate. So the chlorine and the nitrate will not affect the hydrogen concentration. Totally neutral. Okay, so then let's consider a salt that would produce a basic solution. So they're having us consider sodium acetate. In a solution of sodium acetate, the major species or the ions present would just be the sodium ion and the acetate ion, which is C2H3O2 minus. Anything with sodium is 100% soluble, so sodium acetate will dissociate 100%. 100% soluble. Okay, well, now we're going to ask ourselves the two questions. Are there any particles here that have extra hydrogen that could act like an acid and produce hydrogen? The answer is no. Obviously, sodium's not going to produce hydrogen. And even that polyatomic acetate ion, it's got hydrogen in it, but it's not going to let go of them. It's not natural for that to like dissociate and form hydrogen ions. So no, nothing's going to produce hydrogen and act like an acid. The second question, could anything react with hydrogen, remove hydrogen, and act like a base? And here they're giving me a little hint by saying that hydrogen acetate or acetic acid has a really small Ka. So if I wasn't sure, that's hinting at the fact that acetate can react with hydrogen and form a weak acid. And if I know that this is a weak acid, it does not fully dissociate. In fact, it's not going to dissociate by much at all. I mean, strong acids would dissociate 100%. This guy might dissociate like 4%. Maybe like 4 out of 100 molecules will split apart. But most of them stay neutral. So if acetate reacts with hydrogen and forms this weak acid where most of the molecules are connected, the hydrogen is connected to the acetate. That's a way of removing hydrogen from the solution. Oh, if that hydrogen ion concentration is reduced, reduce the hydrogen concentration, then the solution becomes basic if we remove hydrogen ions. And so what you'll find is if you have the conjugate base of a weak acid, you'll get a basic solution. The positive ion is probably a spectator, like sodium or potassium. But the conjugate base of a weak acid is a pretty good base. It's a particle that's really attracted to hydrogen. That's why it's a weak base, because they don't dissociate very much. The hydrogen and the acetate, once they're together, they don't let go. That acetate has a really strong hold on the hydrogen. So if I just have the acetate ion and I put it in a solution, even if there's just sodium acetate and water, here's what's going to happen. Let's see if I can squish it in there. The sodium is a spectator, but the acetate ion, in the presence of water, is going to act like a base. He's going to take one of those hydrogen and he'll form that original weak acid, which is fine. It's just a weak acid and it doesn't really split apart much anyway. But more important, what's left from the water? Hydroxide. And when you've got hydroxide ions, that's the sign that the solution is a base. I totally get that the other particle is it's a weak acid. But like 96% of those molecules will never dissociate anyways. So it's more concerning to me that I'm producing hydroxide. That's going to make the solution a base. So if you have like sodium bonded to any negative ion that comes from a weak acid, you will have a solution that's basic. Check out some acidic salts. All right, so what about something like ammonium chloride? Chlorides are all highly soluble except for silver, mercury, and lead. So this should totally ionize. You get ammonium ions and chlorine ions. All right, well, again, I'm going to ask myself two questions. Question number one, can anybody produce hydrogen? Whoa, right away, that's a yes, right? I've got that NH4 plus 1 ion, and it has an extra hydrogen. It used to be NH3 when it was neutral, but now it's got that extra hydrogen, so yeah, he could let go of that and act like an acid. Chlorine obviously is not going to produce hydrogen, and he can't take hydrogen either because he comes from a strong acid like HCl, and that would totally ionize anyway. So the particle that concerns me here is that NH4. It's the conjugate acid of a weak base. Again, I'm given this Kb for NH3, which is helpful because if I didn't know, oh yeah, that's a weak base. And then it relates to the NH4. How so? Oh yeah, that's the conjugate acid of the weak base. So the conjugate acid of a weak base produces an acidic solution. Because that conjugate acid has the extra hydrogen. So we could just let go of that extra hydrogen, and yep, now I formed a solution that's acidic. So here's kind of what would happen. The chlorine is 100% spectator. The chlorine's not going to add hydrogen, and it's not going to remove hydrogen. But if I have that NH4 ion in solution, which means water's present, well, yeah, that thing's a conjugate acid. If he's acting like an acid, it means that he can donate hydrogen. So I'd be left with the NH3, which I get it's a weak base. The Kb is given and it's small. So I can see it's a weak base, but more concerning is the other product. I'm going to form that H3O+, and that is the sign of an acidic solution.